Okay, Josh has a bag, and that bag contains 10 red circular pieces, 10 red square pieces, 10 blue triangular pieces, and 10 blue star-shaped pieces. We want to figure out, if he draws a red piece of candy from the bag, what is the complement of the event? Okay, so when we look at complementary events are the events that would add everything together. Okay, so when you take a look here, you'll notice you got all the shapes, and the shapes really don't create anything that's too complementary. But if he draws a red piece of candy from the bag, all the remaining pieces then have to be red or blue. And drawing the blue piece is the one that becomes the complementary event. Okay, an online retailer conducts a random survey of its customers. The survey shows that 80% of the customers receive their purchases within 4 days, and 95% of those customers are satisfied with the quality of their purchases. What percent of all customers receive their purchases within the 4 days and are not satisfied with the quality of their purchases? Okay, so in this case, we are looking at the 80% and 95% of the 80% that we have. Okay, so what we have to do is take that 80% and we're going to multiply that by 0.95. Okay, or actually by 0.05. Okay, because what we're looking at here is 95% are satisfied. We want to know the number that's not satisfied. So we're going to take that 80%, we're going to multiply it by the 5% who are not satisfied. So 0.8 times 0.05 gives me 0.04, which is 4%. Okay, we're taking the complementary event to that. Okay, so since we're not really worrying about the 20% that we have, we're looking at the 95% of the customers who are satisfied with the quality of purchases who got their stuff within that first time period slot. Brian records the number of hours he sleeps each night for several days, and whether it's raining in the morning when he wakes up. Brian concludes that the two events are independent, that he sleeps 8 hours or more, and it is raining in the morning. Based on Brian's conclusion that it's an independent event, which statement has to be true? Okay, and Brian never sleeps 8 or more hours on days that it's not raining. That's not it. The probability that Brian sleeps 8 or more hours is the same whether or not it is raining in the morning. And the probability that Brian sleeps 8 or more hours is the same as the probability that it's raining in the morning. Okay, so our correct answer, even though it seems really, really weird, is this one. The probability he sleeps 8 or more hours is the same whether or not it's raining within the morning. Okay, because those two things are independent, it does not matter how those two things work together. A soccer coach determines that there's a 50% chance that a star player, Ralph, will play in the tournament. Probability that another star player, Dan, will play in a tournament is 0.48. Probability that both will play is 0.25. Select a phrase to complete the statement. To find the probability either Ralph or Dan will play, first add, and what you're going to do is Ralph's probability and Dan's probability. Okay, and then what we're going to do is subtract the probability of both. Okay, in other words, if we were to actually have to find the answer to this question, we're going to take the 0.5, which is a 50% probability for Ralph, plus the 0.48, which is the probability of Dan, and then subtract the probability of both playing. And that will give us the probability of one of them playing. Okay, it doesn't tell us which one it would happen to be. A survey is conducted to determine whether a group of 11th graders and 12th graders prefer to go to the amusement park or to the zoo for the class trip. Based on the table, what's the probability that a student preferred a class trip to the zoo given that they were in 11th grade? Okay, so we're looking only at 11th grade zoo people. Okay, so that's going to be 18. Okay, and that's going to be out of all 11th graders, so it's 18 out of 50. Okay, so this 11th grade is my denominator, and it's probably if the student preferred the class trip to the zoo. Okay, it's kind of a weird way to ask that, but that's what they were looking for. Rosa collects data on what students at her school like to eat at a movie theater. She asks a random sample of 120 students 2 questions. Do you like to eat popcorn? Do you like to eat candy? Here's the data shown. The students she asked, 60% of those who like to eat popcorn also like to eat candy. So what we're going to do is we're going to take that 70 people here, we're going to multiply that by 0.6 to find a number of people up there who like candy. Okay, so we're going to take 70 times 0.6, which is 42. So 42% of the people like popcorn. Okay, the people who like popcorn, and that means that 70 minus 42 do not eat candy, so that's 28. 120 minus 70 gives us 50 here. 62 minus 28 will give us 34 here, which means that 16 do not like popcorn and like candy. That means that our answer over here then becomes 58. Okay, we're just filling in a two-way table from there. Okay, questions on that? Okay, our next one, the probability of events A and B are independent. Okay, it's 0.25. So I want to write some possible probabilities for events A and B. Okay, remember that what we're going to do is we're going to multiply two things together. So I'm going to take A times B, and that's going to give me 0.25. Well, one of the easiest ways that you could do this problem is recognizing that you have 1/4. If you take 1/2 times 1/2, you will get 1/4. So if you put 0.5 in for A and 0.5 in for B, you'd be perfectly fine in satisfying that equation. Okay, a baby born in 2011 is randomly selected. What's the probability that the baby was born in February? Okay, we're going to take our number in February, which is 299. Our total numbers in 2011 was 3,966. And that's our answer. Our next one, a total of 50 students play either soccer or lacrosse. What is the probability that a student plays soccer or is a girl? Okay, so we're going to take, we know that we have our total number of students who either play soccer or lacrosse. All right. And we want to know the probability that a student plays soccer or is a girl. Okay. So we need to look for our overlap in this problem, which is the number of girls who play lacrosse. Oof. Okay, we know we're going to have 50. We know we have 20 students who play soccer. And we know that we have 20 girls who play lacrosse. But it doesn't look like there's enough information actually to solve this. Oh yeah, we do. Okay, we have 20 students who play soccer, 20 girls who play lacrosse. Okay, that gives us 40 students total. Whew, a little tough. Okay, just a net reading piece. Okay, university determined the number of students pursuing different degrees by gender. Some of the results are shown. What's the probability a female student chosen at random is pursuing an undergraduate degree? Okay, now, things that we know. Okay, we have doctoral degrees. There's 2,500 total, 500 of them are male. So that means there's 2,000 that slide in here. Now, master's degrees out of those is 4,500, which means that we have 8,000 females doing undergrad degrees. So it says, what is the probability that a female student chosen at random is pursuing an undergrad degree? It would be 8,000 out of 12,500. Okay, and that should be right about 64%. Again, just using two-way tables to find answers to questions. The table shows the voting results of a mayoral election in a small town between candidates Smith and Jones. The small town has 2 polling places, one in the North District and one in the South District. Which statement is true? Jones won the election with 65% of the vote, but we know that's not it because he's not there. Smith won 75% of all votes from the South District, and that's going to be your correct answer right there. Voters' choices are independent of the district in which they voted. Again, I would probably say that that's not really the case. And support for Jones was proportionally higher in the South District than in the North. That's incorrect as well. Probabilities for 2 events, event A and event B, are given. Probability of A and B is 0.14. The probability of B is 0.4. So what is the probability of A given B? Okay, in this case, we're looking for, again, what A is. Okay, so I'm going to look at A, multiply it by 0.4, and that's going to equal 0.14. So I want to take and divide 0.4 from both sides in this case. And when I take 0.14 and divide it by 0.4, I get 0.35, or 35%. The table shows below when tickets for a concert are sold and the types of tickets that are sold. What is the probability that the randomly selected person attending the concert is an adult or has purchased a ticket in advance? Okay, so my adults is 140. Okay, the other piece is the other ticket in advance, which is 40. So that means that our probability for those 2 events is 188 out of 250. Okay. And finally, Maurice has a bag containing 40 small wooden blocks. There are 20 cubes, of which 5 are blue. There are 20 spheres, of which 6 are blue. Maurice randomly selects a cube from the bag. What is the probability that the cube he selects is blue? There are 5 blue cubes out of 20.